The utility of LIMS Nucleus is twofold. First, it allows you to track samples through multi-well plates during rearraying and reformatting operations. And second, it allows you to identify hits in multi-well plate assays. Let's define two terms, sample and target. Sample is what we are tracking through multi-well plates. It might be antibodies, small molecules, siRNAs, maybe plasmids, maybe bacterial stocks. Targets are the entities to which the samples are applied. So for example, in an ELISA, an antibody is applied to a protein that is bound to the plate. Maybe a small molecule is being applied to an enzyme in an enzyme inhibition assay, and possibly siRNAs are being applied to cells in a knockdown experiment. You could also apply plasmids to cells in an expression assay. Regardless of the nature of samples and targets, wells in a multi-well plate need to be designated as a certain type. LIMS Nucleus works with 5 different types of wells: unknown, positive and negative controls, blank, and edge. Edge wells are ignored. Blanks are used for background subtraction. Positive and negative controls are used to set thresholds, and unknowns represent the samples that we are interested in evaluating as either a hit or not in our assay. Consider two different categories of assays: binding assays and affinity optimization. In a binding assay, for example, you might be screening antibodies for binding to an antigen. You would set a threshold that is the mean of the negative controls plus 3 standard deviation units. Anything that rises above that threshold would be considered a hit. In an affinity optimization experiment, you are starting with an antibody that has a given binding affinity. That would be your positive control, and the mean would be your threshold. You are looking for samples that are enhanced in binding above the control. In LIMS Nucleus, we can go to plate layouts and look at an example of a layout. So layout 1 has 4 controls in column 12. So the majority of the plate, 92 samples, are unknowns. Positive controls are in rows E and F, column 12, negative control in G12, and a blank in H12. Most likely, the layout you need has already been predefined within LIMS Nucleus. Select plate layouts, show 100 entries, and search by source. Sort by format, and you can see that there are 2 different layouts defined for 96 well plates. One we've already looked at, 4 controls in column 12. The second has 8 controls in column 12. Note that when you define a layout for a 96 well plate, the next highest density, 384 well plate, into which you will reformat, that layout is predefined. So for example, if you put a positive control in E12 of the 96 well plate, when that plate is transferred in quadruplicate into a 384 well plate, wells I23, 24, and J23, 24 will all have positive controls. Therefore, when you're using the LIMS Nucleus interface and you select a certain layout, what is returned is a set of layouts. The source plate, which is going to be the low density, and then 5 different destination layouts. The difference amongst these destinations is the replication of the source and targets. You can learn more about replication in the replication video. In LIMS Nucleus, this is called the source plate, and the higher density plate is referred to as the destination plate. Though LIMS Nucleus contains a lot of built-in layout files, you may want to define your own. You can do that with a sample layout import file. That is a 2-column file. First column is well, where the integer is the well number. This is by column. And then the type is an integer. On the Lab Solutions layout page, you can see the integer associated with each well type. This particular file has the controls in wells 53 through 56. So it would look like this with the controls in column 7. So if you're interested in that layout, you can download this file and import it. We will import the layout file you can download at this link, and it will provide controls that are scattered across a 384 well plate. So using the LIMS Nucleus interface, select Plate Layouts, and then under the tool icon, Import Layout. Browse and select the file that you downloaded from the website. Once you've selected the file, click Submit, and you will be given the opportunity to confirm that the layout is what you expected based on the import file. Give it a name and then a description. The description can reflect the replication on the plate, and you can indicate where the controls are located. This will take a moment because not only is it creating the layout file that you requested, but it is creating 5 higher density files, destination files, with the same layout. LIMS Nucleus comes preloaded with 44 layouts, so ours will be layout 45. Layout 45, our test layout, 384 well format, scattered controls. This is the source plate. This is the plate that we loaded, and this is what it looks like. But in addition, there are 5 destination layouts that were created. The difference between these destinations is the level of replication. If we look at 1, you can see this is the higher density 1536 with the same layout as the 384 well plate. These control locations are predetermined, which is why we can automatically generate these layouts. Note that layout is an attribute of plate set. All the plates within a plate set must share the same layout. If you need to work with different layouts, you need to create a different plate set for each layout. Also, when grouping plate sets, the plate sets to be grouped must share the same layout. A separate video discusses how LIMS Nucleus handles replication. If you have questions as to the suitability of LIMS Nucleus for your process, contact us at info@labsolutions.com.